Hi, welcome back to College Algebra. This is week 2's lecture. We're going to cover linear inequalities, some compound inequalities, and absolute value equations. We'll cover section 1.4, 1.5, and 1.6 of our textbook, Intermediate Algebra. And here's a list of measurable outcomes that you should understand. So please look over these notes for the week and make sure that after your assignment you understand all of these measurable outcomes. Okay, 1.4, linear inequalities in one variable. So a linear inequality of one variable is essentially an inequality of this form. Ax plus b is less than c. Notice on the left side is a linear expression, and notice that you have instead of an equality, you have less than a constant, less than or equal to c, greater than c, or greater than or equal to c. And we saw previously that a linear equation is where you have an equality here instead of an inequality. And so if I look at the equation x is 3, then x is 3 is just 1 point, x is 3, so it's just one single point on the number line. But if I look at x is less than or equal to 3, that means I want all real numbers less than or equal to 3, so I want 3 and all the numbers less than it. So graphically it looks like this. The interval notation for this is parentheses, open parentheses, negative infinity. So we go from negative infinity all the way up to 3, and then I have a square bracket on the right to denote that we include 3. Opens mean we don't include it, and negative infinity is not a number, so we don't include it. And then if it's less than 3, then that means we have a instead of a bracket, we have a parentheses, meaning we don't include the 3. So this parentheses means that 3 is excluded. And then in the same way, x is greater than or equal to 3 means that it's 3 or bigger. And then if it's strictly bigger than 3, then we don't include the 3. So make sure you understand the inequality as well as the interval notation for these inequalities. Okay, so suppose I have an inequality. If I add or subtract a constant, then the inequality is preserved. In other words, if a is less than b, adding c to both sides of the inequality will preserve the inequality. And if a is less than b, if I subtract c from both sides, then the left side, then a minus c is still less than b minus c. So in other words, adding c or subtracting c again preserve the inequality. And this is true for either less than or less than equal to, or greater than or greater than equal to. So for example, if I have this inequality, I want to solve for x. Again, we can just use the properties of adding and subtracting and see what happens. So for example, I'm going to simplify this parenthesis expression, for example. So I have that 2x, 2 times x is x, 2 times negative 4 is negative 8. And now we're going to try to combine like terms by negative 8 minus 1 is negative 9. And then I'm going to subtract both sides by negative 2x so that I can bring the 2x over to the left. We want to combine all the x's on one side. And we saw that in the last slide that if I subtract two things, that if I subtract the same quantity on both sides, then I keep the inequality the same. So I'm going to subtract 2x on the left and on the right. On the right, we'll cancel this to give you negative 9. On the left, 3x minus 2x is x. I'll keep the negative 7 there. So here's my inequality. X minus 7 is greater than negative 9. Now I want to solve for x, so I'm going to add 7 to both sides. Again, if adding and subtracting will preserve the inequality, I keep it the same. So if I add 7 to the left, that will cancel, I get x. If I add it to the right, I get negative 2. So x is greater than negative 2 is my solution. In other words, this is equivalent to the original. And so my solution set is this, all x that is bigger than 2. So that's the picture, and here's the set notation. All x such that x is greater than negative 2. Or if I want interval notation, then negative 2 to infinity. So notice, make sure you understand all the different ways of denoting this solution set. Set notation, interval notation, and then inequality. Now, if I were to multiply or divide by a number, it turns out that this is a little bit trickier. Whereas earlier when we add or subtract a number, the inequality is preserved regardless of what we add or subtract. But when we multiply or divide, the inequality can change. For example, 4 is less than 5. If I multiply both sides by negative 4, then I get that negative 4 is greater than negative 5. So when I multiply by negative 1, the inequality gets switched. So this says that if a times c is less than b times c, and I divide both sides by c, and c is positive, then the inequality is preserved. So if I divide by c both sides, then it's still less than. But if c is negative, then I take the inequality and I switch it. And so I think this is a little bit of a typo here. AC is bigger than BC. If I divide by C, then yeah, this should be, I should switch this. Oh, so let's see. No, sorry, I misread that. Let me say that again. If C is positive and A is less than B, then if I multiply by C on both sides, then A times C is less than B times C. And A divided by C is less than B divided by C. So again, this is the original. Multiplying by C or dividing by C will preserve the inequality. But if this is the original and C is negative, if I multiply by C, then the less than becomes the greater than. And if I divide by C, again, the less than becomes the greater than. Yeah, sorry about that. So that means, again, the inequality is reversed. So for example, if I want to solve this, I can add 5 to both sides. And remember, when I add, I preserve the inequality. So I get this cancel, this negative 2x becomes is less than 7. This is 7. And now if I divide by negative 2 to cancel the negative 2, the inequality is reversed. And I get that x is greater than negative 7 over 2, which means that x is greater than negative 3.5. And so again, this is the interval notation, and this is set notation, this is the graphical representation. Okay, let's do this another one. Again, I want to solve for x, so I can multiply both sides by negative 3 to clear the denominator. So if I multiply by negative 3, I have to switch the inequality. And so this will cancel. On the left, it's just negative 5x plus 2. On the right is I'm going to multiply this in. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Now I'm going to move the x's on one side to combine them. So I'll add 3x to both sides, for example, so that this will be gone. I'll bring this over, and this become negative 2x. And then finally, I'm going to subtract 2 on both sides to get negative 8 on the right side. And finally, I divide by negative 2. When I divide by negative 2, the inequality is switched to from less than to greater than. So x is now greater than 4. And the solution set is the interval notation is from 4 to infinity. Yeah, so that's basically how we approach that problem. When you're not sure of your answer, you can also check your answer by picking test points. For example, in the previous problem, once I get the answer that x is greater than 4, if I'm not sure if that's right, I can double check by plugging something that is on the left side and also on the right side, make sure that it checks out. So for example, if I plug in 0, I get that negative 2 over 3 is bigger than 2, which is false. That means that this side is not the solution. If I plug in 5 on the right side, I get that 7 2/3 is bigger than 7, which is true. So you can always double check your answer. Okay, suppose that Beth received grades of 97, 82, 89, and 99 on her first 4 tests. To earn an A, she needs to have an average of 90 or more. So the question here is, what score must she receive on the 5th test to get an A, which is again at least 90 or more? Well, we can call X be the 5th test, and the average of the 5 tests is adding them, divided by 5. And to earn an A, this average has to be bigger than or equal to 90, at least 90. So the average has to be bigger than 90. So I'm trying to solve for X. So I multiply both sides by 5. This is a positive 5, so I keep the inequality. For example, by the way, before that, I should combine these these terms to get 367 plus x divided by 5. Then multiply both sides by 5, so that this will cancel, and the inequality is preserved because this is a positive 5. And then I subtract 367 from both sides to get the x is greater than or equal to 83. That means that Beth has to score at least an 83 to get an A on her for her grade. Okay, 1.5 compound inequalities. So the idea here is that we may have 2 sets A and B, and we want to combine them by using the union or the intersection operation. So if A union B is a set of all elements that belong to A or B, or to both. So when you union, you're basically combining the two sets. So your A union B is now either the set. It could be bigger than or equal to the original. Depends on what the original sets are. If I do an intersection A and B, then A intersect B denote the set of all elements that is in both A and B. So here's the picture. If I union two set, then I basically get a bigger set that includes both. If I intersect them, then I only get the set that of elements that is in both. So I could possibly get something the same or smaller. So we say that sometimes we say this is an OR operation. The union is an OR. Intersection is an AND operation. So for example, let's look at these sets. If you have x is less than 3 and x is bigger than or equal to -2, and I say I want the intersection of A and B, well, graphically, the set A is again less than 3, set B is greater than or equal to -2. If I intersect them, I want points that are in both. That means notice the points that are in both of these is basically from -2 up to and not including 3, because these are the points that is in both here and here. And so the intersection is the overlap, is from -2 up to and not including 3. So -2 has the bracket and 3 has an open parentheses. What if I want to do a union? That means I'm trying to add them. So here's A and here's C, and I want to union them. So that means that I want the set of all points that's in A or B. So that means when I union them, I get the biggest set that basically is now both of them combined. Okay, how do I solve this compound inequality? This is an AND. So basically we solve them separately like we did earlier, and then we just combine them with an AND, which is an intersection. So for example, on the left side I divide by -2, so I switch the inequality, so I get x is greater than -3. On the right side I subtract by 5 both sides, I preserve the inequality, x is less than or equal to 2. So I want an AND, so here's bigger than -3 and here's less than or equal to 2. If I want to AND them, I want the points that are in both, so it's between -3 and up to including 2. So the intersection is exactly these points that are in both. And notice either the set notation or the interval notation. Okay, what if I have something like this? Well, this is another AND example. So again, I solve them separately, and then at the end I just find the intersection of the two solution set. So for example, on the left side I subtract 3.1, then I divide by 4.4. This is definitely a calculated problem, and I get the A is less than -3.5. Notice when I divide, I keep the inequality because this is a positive number. On the right side, again, I subtract 9.1, then I divide by -2.8. So I switch the inequality, and I get A is bigger than 5.5. So here's the picture. This is less than -3.5. This is greater than 5.5. I want to find a set of all points that are in both this one and this one. You see from this picture that's not possible. You cannot be in this set and in this set at the same time. So the intersection of these is actually the empty set. You just say you can just write curly braces and nothing inside the set notation. So this is the empty set. So that means that there's no solution to this compound inequality. So another kind of compound inequality is when you have something like this, where it's A is less than x, it's less than b. So x is bigger than A, and x is less than b. So this inequality, this compound inequality, can be broken down into A is less than x and x is less than b. So this is an intersection. This is a way to kind of denote intersection. So this means that this expression is both bigger than -4 and less than or equal to 10. So the way to solve this is one way to solve this is to do them separately, and then use an AND intersection at the end. This is actually the kind of the longer way of doing this, but I'll show you this way, and then I'll show you another way that's a bit better in the next slide. So I can do the left side first. This is bigger than -4. So I solve them normally like before. Subtract 5, divide by 3 to get this inequality. On the right side, I have this expression is less than or equal to 10. Again, I subtract 5, divide by 3, x is less than or equal to 5 over 3, and then I AND them at the end because this is an AND. So x is bigger than negative 3 and less than or equal to 5 over 3. So that's my solution set. This is one way to do this. Another way of doing this is actually, I'll show you another way of doing this, but maybe a different problem. Again, same thing here. This is an AND, but instead of breaking it down into two separate problems like this, instead of doing two different problems, we can do the same. We can solve it all simultaneously by operating on all three expressions at the same time. So, for example, I want to clear the denominator here, so I want to multiply everything by negative 3. This by negative 3, this by negative 3, and this by negative 3. But by doing that, I need to switch the inequality. Switch this one to less than or equal to. Switch this one to less than or equal to. So now as I simplify negative 6, this will cancel. And now, again, whatever I do, I have to apply it to all three expressions. So now I'm going to add 2 to everything because I want to solve for p eventually. I add 2 to this side, to this, and to that. I add 2 to this, I get negative 4. If I add 2 to this, I get just p. I add 2 to this, I get 5. So this is my final answer. Notice I solve the AND by doing everything all together rather than breaking it down into two different problems like earlier. And this is the solution set between negative 4 and 5, including both endpoints. Okay, this is an OR. So for an OR, then you definitely need to do these separately and then combine them at the end. So add 5, divide by negative 3 on the left. Remember to switch the inequality. Subtract 4, then divide by negative 1. Remember to switch the inequality. So I'm less than negative 3 or bigger than or equal to negative 2. So here's the picture, either on this set or this set. So if I or I union the sets, I get both of them. So I get this new set that is that includes both sets. So the interval notation is I have to say from negative infinity to negative 3, not including, union from negative 2 including to infinity. So I notice I use the union to denote this interval notation. Okay, this is very similar to the other one, so I won't go into it, but I'll just say that once I solve the two inequality, notice I have this and this, and if I want to OR them, if I union this set and this set, notice that if I add these two sets, I actually get everything. So the union of these two sets is actually the entire number line. So the solution set is, you can say x such that x is any x such that x is a real number, or you can just say from negative infinity to positive infinity. In other words, all real numbers. So the thyroid is actually a gland basically at the lower part of your neck, and so a lot of adults who has a thyroid that doesn't produce enough hormones called TSH, then they often have to get tested to make sure that the level is the right level. If not, they have to take medication. And so the normal level for TSH is from 0.4 to 4.8 microunits per milliliter. And so let X represent the amount of TSH, and we're gonna answer a couple questions about this range. So write the inequality representing the normal range of TSH. So that's easy. You just say the X is greater than or equal to 0.4 and less than or equal to 4.8. Let's write a compound inequality that represents the abnormal TSH level. So whatever is not normal. Well, if you're not inside of this interval, you must be outside of it. So you have to be either less than 0.4 or bigger than 4.8. So either x is less than 0.4, that means you're on the left side, or you're on the right side, which is bigger than 4.8. Okay, 1.6 is the absolute value equations. So the equation absolute value of x equal to a is called the absolute value equation. And this absolute value equation denotes distance from 0. So if I say absolute value of x is 4, I mean that the distance between x and 0 is 4. So I can either be at negative 4 or positive 4, because if I'm at negative 4, my distance from negative 4 to 0 is 4. If I'm at positive 4, my distance from 4 to 0 is also 4. So I'm looking for all x such that the distance between x and 0 is 4, and these are the two solutions of that equation. So the idea is that if you have absolute value of x is equal to a, then x is either equal to a or x is equal to negative a. If a is non-negative, but if a is negative, this equation has no solution. Because absolute value denote distance, you cannot have a negative distance. So let's solve these individually. Absolute value of x is 5 means x is either 5 or negative 5. So my solution has two solutions, 5 and negative 5. If I solve for absolute value of w here, again I need to solve for absolute value first before I do that trick. So absolute value of w is 14, so either w is 14 or negative 14. Absolute value of p is 0 means either p is 0 or negative 0, but that's the same thing, so the solution set here is just 0. And finally, the absolute value of x is negative 6. That's not possible. There's no solution to this because the absolute value has to be non-negative. Now, if I want to solve something more complicated, I should do the same trick. I say that the absolute value expression has to be either 5 or negative 5. So this breaks down to two parts. Either 2w minus 3 is 5 or 2w minus 3 is negative 5. If I solve for this, I get that add 3 to both sides, divide by 2. So w is either 4, or if I solve the other side, w is negative 1. So I have two solutions to this absolute value, 4 and negative 1. I can't do anything with this until I isolate the absolute value. So I subtract 6 on both sides to isolate the absolute value. And so now 2c minus 5, absolute value is negative 4. Notice you cannot have a negative. Absolute value of anything cannot be negative, so this has no solution. And this is again similar. I always want to isolate the absolute value, so I'm going to add 7 to both sides and then divide by negative 2. So if I do that, I get negative 12 divided by negative 2 give me positive 6. Now that this is isolated, I can say this absolute value expression is either 6 or negative 6. And the same way, I just solve for this by, for example, minus 3 multiplied by clearly when this again, there's a lot of ways of doing this. You can minus 3 and then multiply by 5 and then divide by 2, or you can just clear the denominator by multiplying everything by 5 in this case to clear this denominator. And then eventually you solve, you get p is 15 over 2. On the other side, you get p is negative 45 over 2. So those are my two solutions to the original absolute value equation. And if I have two absolute values, it's the same thing, except that, so absolute value of x equal to absolute value of y means that either x is y or x is negative y. So notice I have two absolute values, so let's do two things. Either 2w minus 3 is 5w plus 1, or 2w minus 3 is equal to negative 5w plus 1. And so I just solve for individually. So I solve the left side. Again, I bring all the w on one side, and then bring all the constants on the other side, and then solve for w. Notice, be careful here, this negative applies to the entire parentheses, so it has to be distributive inside. So this is negative 5w minus 1. So notice that negative distributes into both of those expressions. Again, solving for w gives me 2 over 7. Same thing for this one. Either x minus 4 is x plus 8, or x minus 4 is negative x plus 8. If I do the left side, I get a contradiction. Subtracting x on both sides, I get negative 4 is 8. That's not possible, so this gives me no solution. On the right side, if I solve for x, I get negative 2. So this absolute value equation have only one solution, which is negative 2. Okay, that's it. Thanks for watching.